Hello, this is Mark from I Am Organic Gardening, located in Zone 6B in the state of New Jersey, on this beautiful day in the middle of March. And welcome to Part 7, Soil, How to Grow Nutrient-Dense Fruits and Vegetables. So as promised in Part 6, I'm going to continue to talk about mycorrhizal fungi and how it actually builds soil or grows soil. So my example here with this large sponge is that's what we want our soil to be like. We want it to be like a sponge. Lots of air spaces in there, but we want it to hold its shape in place when the water leaves it, so more water can come in, more air can come in, and thus we can give more room for life of the bacteria and fungi in the soil to grow, so that can be eaten by the protozoa and the nematodes and release those nutrients back to our plant. And the more we build the soil, the more the colony grows, the more nutrients there are recycling, and the more carbon being sequestered out of our atmosphere back in our soil again, and everything is working great, and that plant is going to be super healthy, super strong, and great tasting produce. So the soil that you see in front of you right now does not have actively mycorrhizal fungi growing in the soil because there is no living root. It has to have a living root. So in the next week or so, I will be planting some cover crops in here to get that living root established so I can start building mycorrhizal fungi in the soil prior to planting my vegetables like my tomatoes and other things in my garden, so I have actively growing mycorrhizal fungi in the soil that can help those other plants get adapted quickly as soon as I transplant them in the ground or add seeds. I'd like to show you this illustration again. This is what I also used in part 6. Now, I'm just going to briefly explain. What I'm going to show in a demonstration shortly using this purple straw here, or light purple straw, is how mycorrhizal fungi build soil. Again, one single root is coming down here. Here we have the root hairs. Now, with all this mycorrhizal fungi, these little strands here are called hyphae, and then we have our spores here. This hyphae extends out of the cells, of the individual cells of the root in endomycorrhizal fungi. Now, this builds soil. It is growing soil. Without this, you are lacking one particular thing. Now, when this goes in the soil, it's such a thin filament. You need a magnification about 400 to see it. It's not something you can see with the naked eye or even come close. It's in your soil. Now, when this goes into your soil, these fine filaments that are of the mycorrhizal fungi hyphae that go through the soil, I want you to think of it as just as, let's say, as workable as a worm going through soil, creating openings and pushing the particles of the soil away. This just does it on a very small scale, making micro and macro pores in your soil. Very, very small pores. But what they do here in this is they make soil aggregates. And that takes let's say particles in the soil, makes them into an aggregate, and then opens things up just like the sponge, creating air gaps. So now we have more air in our soil for better roots, and we also can store more water inside our soil also too, so our plants aren't stressed. Now this is very interesting. So again, I'm going to show you a demonstration how this works, and what is so cool inside this mycorrhizal fungi through the use of this purple straw again is this amazing thing that actually comes out of the mycorrhizal fungi and builds soil aggregates in the next demonstration. So in this demonstration, like I mentioned before, the purple straw here is a single strand of mycorrhizal fungi hyphae. It can be either endo or ecto. Now, what's nice about this is that it's moving through our soil particles that we have in our soil. So imagine we're looking at this again at 400 magnification, at the very minute. So this piece here, which contains lots of soil particles, just imagine that as one soil particle, and our fungal hyphae is moving through the soil, growing. Now it's growing because, again, the plant is providing its food and water, and it's exchanging things with the plant, minerals, and it continues to grow in the soil. And what it does, something now is amazing. It produces something called glomalin. And what this glomalin does is that it will build soil. It will take all these particles and glue them together. That's what glomalin is. And this fungal hyphae can do this because it's getting all the proteins that it makes itself and also from the plant. And I will demonstrate what it looks like or what it does. Now, again, this is just a small demonstration I had to come up with. There is no recording actually at building or else too. But this will give you a good idea that basically after that hyphae goes through the soil, and it's such a minute micro and macro portion of the soil and building it, it's going to glue all these particles together with this glomalin. And then I'll show you how it does it. So let me explain what happened. It produces this glomalin, which is a kind of glue that comes out from the hyphae and glues all these particles together so it can create something called a soil aggregate. And once that soil aggregate's in place, this glue dries and then basically creates air gaps between these spaces here and keeps them open so water can go through and also air can stay there. So every surface that you see now, it's not filling up the soil, it's just lining everything to create this like channel way here to allow water and air to go through your soil. And it's just amazing. But the best thing is, again, too, this is not permanent. It actually has to replace itself every 30 to 60 days in the soil. So it needs that living root. It is not delicate, but it can't be tilled. It cannot be destroyed by mechanical surfaces from the top to destroy these soil aggregates now. So again, this mycorrhizal fungi hyphae will exude glomalin and keep these soil particles open. So without that living root, you don't have the mycorrhizal fungi hyphae and you don't have the glomalin to make soil aggregates. And that's nature all the time working. If, again, you can add things to your soil and create your own air gaps, but it will not stay open for long periods of times, that's the purpose of mycorrhizal fungi exuding something called glomalin. That's the glue inside this to make aggregates. And that's how you build or grow soil. It has to have, I have been saying it so much, that living root in the ground all the time as long as possible to keep everything working, to recycle nutrients and keep your plants healthy. So when we add our organic matter to the top of our soil, our leaves, our wood chips, or any type of other organic material to help grow soil, it's only helping the top surface grow, not below where most of the roots are from your plants. We want to continue that growth down into the soil. What's happening is just the organic matter is helping that top part stay open through the help of the bacteria and fungi. But we want to go deeper into our soil to make that colony larger. That's the purpose of the mycorrhizal fungi and also of building and growing soil. So your leaves and your wood chips will help the top part of the soil, like to say the first like 1, 2, or 3 inches, but we want it to grow further down in the soil. We want that mycorrhizal fungi to go anywhere from 3 inches to 2 feet down in the soil or even more. Like trees in a forest, those roots extend down 20 feet in the ground and they have mycorrhizal fungi growing on the bottom of those root tips into the soil, even extending further. It's endless how deep the mycorrhizal fungi can grow in your soil, but again, it's not worried about so much the surface. Now here's a very good example of what the endomycorrhizal fungi would look like underneath a microscope at 400 magnification. This is an actual picture of it. Now you can see that it's very thin strands coming from everything, and the larger globes here is the spores that it will grow to reproduce itself in the future. And also if a root comes down below here, in between or across or next to it, that these globes will send a signal to those roots and open up and release spores to the roots to help that other plant get adapted to mycorrhizal fungi. Now again too, nature is doing this all free of charge in the soil. The only thing you don't have to do is you can till the first time to get your soil kind of loosened up and then get that living root in the ground to establish this mycorrhizal fungi. But after that, never do tillage again. You can rake the surface and upset the soil to about maybe an inch, but you do not want to go lower into the soil, breaking up this fungal hyphae with any kind of mechanical disturbance. Now, I will also be talking in the future about using a broad fork. Now, it will damage this in certain areas, but if you use a broad fork properly, you will make large, let's say, chunks of soil that are not disturbed, and this can flourish again, but you're just opening up that soil just a little temporary bit to get those roots in there and air in there to aid in doing it. Now, broad forking does not have to always be used. You only do it like maybe the first couple years to establish your plants and your garden soil, and then from then on you stop. There's no reason to use it anymore. And what broad forking is a tool that people use, and they will push this into the ground. These spikes are usually anywhere from 8 inches to over a foot long, and it will just break up that soil just a little bit. And I will make a separate video in the springtime about how to use the broad fork properly. But this will just loosen up the soil so you don't have to till or dig it or nothing else either. Again, there's a proper way to use it. I will make a video on it, and you do not ever have to rototill your garden. Now, you don't have to use a broad fork if you don't want to. You can use, again, just roots in the ground, or you can even use a pitchfork or something like that to start out, again, with your garden soil. In the beginning, you're allowed to do this, but after years have gone by, you have to stop the usage of it because you don't want to ruin the microorganisms in the soil. Now, here's still another amazing thing about mycorrhizal fungi, is that we have two samples here. We have our clover on our left-hand side, and we have our little miniature corn stalk over here on our right-hand side. Now, with that mycorrhizal fungi in the soil, sharing the same type of mycorrhizal fungi, that these plants can communicate with each other, asking each other for water and nutrients from each other. Plus, if they were both the same plant, both clover and both corn, that they can communicate with each other and warn each other through sugars and say signals sent from one plant to another plant, that let's say one corn plant is being attacked, it will alert the other corn plants in the same area that are connected by the same mycorrhizal fungi that there's danger presence from either pest or some type of fungus. Now, this is all being done in nature all the time. It has been this way for thousands of years, and this is how plants survive. They work with each other. They don't work against each other. So a lot of people ask, well, gee, with all these roots in the ground, aren't they competing for nutrients and space and water? Yes, they're going to compete against water to some extent, but also too, if you have all this living down here below in your soil, you're enhancing the soil's structure so much that it can contain more water than just with a single plant trying to grow by itself. It's making all those air gaps from all that mycorrhizal fungi growing in the structure of the soil, opening it up more and creating more colonies, more bacteria, more fungi, that you'll have. It's unlimited how much space, more space you'll have by just leaving that soil alone. So for everything that we think that we're doing right by tilling the soil or else too, it's not really that correct in doing that, because what you're doing is you're crushing all the air spaces. It's almost like crushing that sponge and holding it down in place and not letting the air back or water back into that sponge again. I want to thank you very much for watching today's video, and in part 8 I will be going over how to plant up some cover crops in the soil, weather permitting, outside. next week and see if we can get things started in the garden. If not, I can build a raised bed and show you a new design I have. But until then, I thank you very much for watching. If you can, please like and share this video. And yes, this is a picture of one of my beautiful amaryllis that I grow in my house over the winter time to keep some green growing around me. Thanks. I'll see you soon. Bye.